So we have three ways of undoing exponentiation to solve an exponential equation. The first method is simply to use the logarithm whose base matches the base of the exponential. This would be the standard approach to undoing any operation, is to simply use the inverse operation with the same parameter or the same constant attached to it. Now, the idea here is that there is a property of logarithms that says that if we have a to the x, and we then take the logarithm base a of a to the x, that we obtain x. This is based on the concept of inverse functions, that if we perform any action and then immediately perform the inverse action, those two actions cancel each other out and return us to the value with which we began. So the idea here is that, like anything we do to solve an equation, when we add 5 on one side, we add 5 to the other side. If we divide one side by 2, we divide the other side by 2. The idea here would be that we will use a logarithm. Now let's give some actual values here. That we would use a logarithm whose base matches the base of the exponential, and we would do it on both sides of the equation. So we would do logarithm base 5 of 5 to the x. And on the other side, we would do again logarithm base 5 of the 18. What happens on this side then is exactly the logarithmic and exponential inverse property that we just saw. The logarithm base 5 cancels with the exponentiation base 5 and leaves us with just the x. And on the other side, we now have logarithm base 5 of 18. And that is, well, that's the exact form of our solution. Now, that's not particularly meaningful, I'll grant you that. So this is where we'd probably go to a calculator. The way we would evaluate this is using the change of base formula, which means we can use any other base we want, but the two the calculator understands are the common logarithm and the natural logarithm. So we can use either one of those and do the logarithm of the value 18 divided by the log of the base 5. And again, we could also have used natural log of 18, natural log of 5. And it would give us the same result either way. Calculator is, there it is. Misplaced it. So, quick run through the calculator. Now, be very careful when you're typing this in. Again, on your calculator, when it gets typed in as log 18, you have to make sure to close that parenthesis off before you put the division by the logarithm of 5. And what we get is, well, not a very nice value, but unfortunately with exponential and logarithmic functions, that tends to happen quite a bit. A good standard way to write it is to give 4 decimal places, no rounding, unless you are specifically instructed to do so. 4 decimal places with a ... after to signify that there is more that is not being written. That is the first and standard way to solve an exponential equation, by using the logarithm with the same base.